Up to this point in pre-calculus, we've been using trig functions or trig ratios to solve triangles, right triangles. But in Chapter 10, we're going to learn about the law of cosines and the law of sines. So in Section 10.1, we're learning about the law of cosines, and we're going to learn to solve oblique triangles, that is, triangles that are not right triangles, by using the law of cosines. So first of all, let's talk about triangles in general, and then oblique triangles. So oblique triangles are triangles that do not contain right angles, as I spoke of earlier. And then standard notation for these triangles is going to be such that capital letters are used for the angles. You notice here, capital letters. And then opposite those angles will be the lowercase letter referring to the side opposite those angles. And you can see that in both cases. So here we have angle A, and then opposite that is side with length A. All right, so the law of cosines is c squared equals a squared plus b squared minus 2ab times cosine c. And you can do that to find, so here you're going to find the square of side c. There's also a version of that that you'll see in a minute for finding the square of a and the square of b squared, or the square of b. And then different versions of those to find angle measures, which can be derived from this equation that we have here. So let's go ahead and look at those. So here are the different versions. So you've got a squared. Okay, so if you were solving for trying to find the length of side A, then you would use this. If you were finding the length of side B, you would use this. And if you were finding the length of side C, you would use this equation. So it all depends on what you're looking for. And again, that is the law of cosines. So when can you use this? It's going to be when two sides and the angle between them are known. And this will make more sense in a few minutes when we look at an example. But when you have side, angle, side information. So that would be, an example of that would be, we're given the length of that side, we're given the length of that side, and then we're given the angle measure here. If we're given that information, then we could find all the missing pieces to that triangle. Meaning, I could use that information to find this angle, the measure of this side. And we could also do use the law of cosines when we're given side, side, side information. So given a triangle and we're given side, side, side information, if we have all of that, then we can go and find the measure of this angle, the measure of this angle, and the measure of this angle. Now, as for proof of the law of cosines, we're going to do this in class, but if you want to get a head start and look at that, then you can look in your textbook for that, and that's on page 621 in your textbook. But again, we will go through the proof for the law of cosines in class before you begin your work. And now we're just going to start looking at some examples here. So here's the first one. We're going to use the law of cosines to find B in this case. So you notice what we have here is we have an angle and we have two sides. So this happens to be side, angle, side information that we have here, which means that we are able to use the law of cosines to find the value of B. Okay, so when we start that, we're going to start with the version we need to know. We're finding B, so we're starting and using B squared. So we know that B squared is going to be equal to 8 squared plus 5 squared. So the two sides that you do know, minus 2 times each of the sides that you do know, which we know are 8 and 5 now, times the cosine of the angle measure that you have, which is your 77-degree angle. Okay, and we're going to simplify that to find that B squared is equal to approximately 71.0039. And now if you just leave that in your calculator when you simplify that, if you leave that in your calculator and raise it to the 1/2 power or raise it to the 0.5 power, then you're going to find that B is equal to, or is approximately 8.43. And so there we go. We have now used the law of cosines to find the value of B in that case. This is something we would not have been able to do without the law of cosines because we don't have a right triangle here. This is an oblique triangle. All right, moving on to the next example. Sometimes, like in this example, we were asked to find B, but what if we had been asked to find the measure of angle A or the measure of angle C? We could use the formulas that we have to do that, but you can also use a simpler version. If you would prefer, you could memorize a simpler version of the formula, and the formula that I'm talking about is here. So let's think about how we get that formula. First of all, we have the formula C squared is equal to A squared plus B squared minus 2AB times the cosine of C. So if we're trying to find the measure of angle C, then what we need to isolate is this here. And right now you notice that the sign is negative. So what we want to do is move that to the other side of our equation by adding that to both sides. And then I would at the same time take this and move it to the other side of the equation. So what that's going to leave me with is 2AB cosine C is equal to A squared plus B squared minus C squared. And now once I have that, I want to isolate my cosine C here. So to do that, I'm going to divide by 2AB on both sides. Those cancel, and that's how I arrive at this formula here. And we can do that for each of the angles. Okay, so now we're going to practice using that. Here's a case where I have side, side, side information. And we know since we do have side, side, side information, we can use the law of cosines to solve this triangle. So we're going to find the angles of triangle RST using our law of cosines. So when we start out, you might want to start with finding, let's say we want to start and find the measure of angle T. So I would say that cosine of T is going to be equal to 70 squared plus 90 squared minus 40.5 squared. Notice that the one that is subtracted is opposite the angle measure that we're trying to find. All of that is divided by 2 times A, which in this case is a 70, and then times 90. Okay, and then we use our calculator to simplify that, and we find that the cosine of T is approximately 0.9016, and I'm taking this to the 4th decimal place here. Now, from that, we know we have to use our inverse cosine to find out, or our arc cosine to find the value of T, and make sure this is in degree mode because we're trying to find the measure of these angles in degrees. And once we do that, we find that T is approximately 25.63 degrees. Okay. Okay, so now we have the measure of angle T, and us. So now that we have that, we're going to look to find measures of other angles. Okay, so the next one I'm going to do is S. All right, so to find the measure of angle S, then I have cosine of S is going to be equal to 90 squared plus 40.5 squared minus 70 squared. All of that is divided by 2 times the 90 times the 40.5. And going to simplify that, and I find that the cosine of S is approximately 0.664. And again, I need to use arc cosine here, and I find that the measure of angle S is approximately 48.39 degrees. Okay, so now I have two two of the three angle measures. And once I have two of the three angle measures, then all I have to do is use, we know the sum of the interior angles of a triangle is 180 degrees, so I can use that to find the measure of angle R. So once I do that, then the measure of angle R is going to be approximately 106 degrees. Okay, so we have this, this, and this. And I've solved that triangle. Okay, here we have an application problem, and this time you notice that we're given side angle side information. And so you've got a ship R. Okay, here's our ship R. And it's going to be leaving the port P, and it's going to travel at a rate of 16 miles per hour. And then another ship Q is going to leave the same port at the same time, and it's going to travel at 12 miles per hour. So I gave you a little more information here in this diagram, but if you're traveling at 16 miles per hour here, and you're traveling for, it's going to tell you in just a few minutes that you're traveling for 3 hours, then 3 times the 16 is going to give you 48, and another traveling at 12 miles per hour, and that's how I get the 36 here in my diagram. Okay, so it tells us that the directions taken by the two ships makes an angle of 55 degrees. You can see that. And how far apart are the ships after 3 hours? So basically what we're trying to find is P. And so then we're going to use that P squared is going to be 36 squared plus 48 squared minus 2 times 36 times 48 times the cosine of 55. Okay, we are going to simplify that, and once we do, we end up finding out that P is approximately 40.22, and that's going to be 40.22 miles that we get after 3 hours. And here's our answer. Okay, let's move on to the next example. In this example, what we have is a factory conveyor belt, and it's going to make an angle of 17 degrees with the horizontal, and it's going to rise from point Q on level 1 to point S on level 2. So the original belt that we're talking about is this here in green. It's going from point Q to point S. And it makes a 17-degree angle with the horizontal, and that's our 17-degree angle. And it's going to need to be replaced. So a design change is going to call for a vertical post RT, and its dimensions are shown in the diagram, and that's here. That's our vertical post. And once we have this vertical post, then we're going to have a new conveyor belt. And we're looking for the length of this new conveyor belt. So here's our new conveyor belt here in red, and we need to know how long that is. So we're going to use the information we have here to find the length of that conveyor belt. So you notice looking at that, we don't have side angle side information. We've got side. We're going to look at it as two different triangles. So side, side, we're missing this angle here. So if I want to find that angle, then I can use the fact that this is a 17-degree angle. We know we have a 90-degree angle here, and once I use that, then I know that I have 180 degrees in a triangle, which is going to make this angle here 73 degrees. And if that angle is 73 degrees, then I know that this angle here is 73 degrees, and I know that this angle here is supplementary to that angle, making it 107 degrees. So, okay. So let's look at okay. All right. So now that I have that, we're going to look at this as two separate triangles. One of the triangles is going to help us find out what the value of P is. The other triangle is going to help us find out the value of U. So I'll start by finding P. So I can say that P squared is going to be equal to 72 squared plus 40 squared minus 2 times 72 times the 40 times the cosine of 107. And I simplify that and find out that P is approximately 92.02. And then, once I have that, then I can go ahead and find U. So I can say that U squared is going to be 40 squared plus 64 squared minus 2 times 40 times 64 times the cosine of 73. And then I use all that to find out that U is approximately 64.81. And then then I add the two together, U plus P, and I find out that the length of the new conveyor belt is about 156.82. And let's see if we have any units with that. We were not given any units for that, so we're just going to say units. Okay, and here's our answer. And that concludes our examples for section 10.1.